Hi, hello everyone. So this is Ravinder Pasula. Now in this video, we are going to learn about mathematical understanding of the linear regression. Now first of all, what is linear regression? So in last video, we have seen linear regression, its applications, types of linear regression, etc. So linear regression is a learning model. It comes under a supervised learning algorithm. In linear regression, we can predict outcome. That outcome depends on input variables called independent variables. We can plot on x-axis. There are different types of linear regression: simple linear regression and multiple linear regression. And simple linear regression, that independent variables, input variables, impact on a dependent variable. That means dependent variable depends on independent variable. So according to the simple linear regression, if dependent variables depends on only one independent variable, that is called simple linear regression. And whereas comes to the multiple linear regression, the dependent variable depends on multiple number of independent variables. That means multiple inputs influence on outcome. That is multiple linear regression. And coming to the applications of linear regression, we can predict outcome. For example, at present my salary is 50k. Now watch my salary after 2 years. This is what I am predicting my salary after 2 years. So we can forecast trends. Like these are some applications of linear regression. And now in this video, I am going to explain about understanding linear regression mathematically. Understanding the linear regression mathematically. Now, actually, the regression analysis is a form of predictive modeling technique which investigates the I'll repeat 1 second. Coming to the regression analysis. So, regression analysis is a form of predictive modeling technique which finds the relation between independent variable and dependent variable. So we can find out relation between simply independent variable and dependent variable. How many independent variables are influencing dependent variable? Now here we can plot a independent variable on x-axis and we can plot all the outcome on y-axis. So this is what linear regression. Yes. Now here, while increasing the x value on x-axis, the y value may be decrease or increase, that doesn't affect. Now for example, once y value increases, that what about x value? X value may be, yes, once x value increases and y value may be decrease, increase, or doesn't affect. Okay. If y value decreases, then what about the line come down? That means what? Independent variables negatively impact on y value. If while increasing x value, it doesn't affect on dependent variable, so that is what the b1 is equal to 0. It doesn't affect on. That means the value moves right, straight line. That means what? Independent variable doesn't impact on dependent variable. Now while increasing x value and y value automatically increases, that is what positive increasing. So this is what a line of regression line. So this is what a line of regression line. That means, the x value is positively impact on y value. If x value negatively impact on dependent variable, if x value negatively impact, that means once x value increases, y value decreases, that is what, that means independent variable negatively impact on dependent variable. So that is what, negatively impact. Once x value increases, but if doesn't affect on y value, in that case, the regression line will goes like this. So this is what a positive impact, this one is negative impact, and this one is what doesn't impact. So this is what a small introduction about regression. Yeah. Now coming to the plotting point of view here, how to plot data points on both the x-axis and y-axis. Once value in increasing on x-axis, that is independent variable, right? Now y value also increases. Yes, once x value increases, automatically y value increases. That means that value independent variable positively impact on dependent variable. Now how to plot? For example, here the value of x is 1 and value of y is 3. Now if you want to plot these values on x-axis and y-axis, now here the x value is 1 and y value is 3. Yes, we can plot it. Yes, x value is 1 and y value is 3. So like we can plot. Right. Now coming to the next row, x value is 2 and y value is 4. So x value is 2 and y value is 4. So in that case, we can plot the point here. Now next data point is what? X value is 3 and y value is 2. So x value is 3 and y value is 9. So like we can plot all the data points on both axes. After plotting all the data points on x-axis and y-axis, that means independent variable and dependent variable. Now we have to draw the regression line. Now representing the linear regression model. So linear regression model represents the relationship between dependent variable and independent variable. Already we have seen in previous slides. Now the formula here of linear regression is, one second, I'll repeat. Yeah. Representing linear, 1, 2, 3 start. Representing linear regression model. Now in this slide, we'll discuss about how to represent a linear regression model. So this linear regression model represents and find out relationship between independent variable and dependent variable. Yeah, this figure will shows that what are data points and how to plot the line, the what are input variables and output variables. So this line is what a line of regression. These are all data points. So the value, this one is the independent variable, this one is the dependent variable. The sloped straight line represents the linear relationship that fits the given data best. It is called as regression line. That means after plotting these many lines, we have to draw the best fit line along all the points. Sometimes some data points may miss. That is what error. We have to reduce that. We have to minimize the error. So that best fit line also called as what, line of regression. Yeah. The coming to the line of regression the formula. So y is equal to mx plus c is the line of regression formula. Now this is what we can understand the mathematical way. We can represent the mathematical way of y is equal to mx plus c. Now here we have to calculate x minus x bar. So here x is the independent variable and x bar is its mean. Now y is the here output variable, that means dependent variable. Y bar is the what? Its mean. Then we have to calculate x minus x bar square. Yeah. So after getting all the inputs and outputs, then we have to plot it. So this is what a line of regression. Then we have to find out. Now if you want to draw this line of regression line, so we have to calculate the formula. M is equal to sum of x minus x bar into y minus y bar by sum of x minus x bar whole square. So we have to find out this formula. Then we'll discuss one by one. We'll discuss one by one these, the mathematical formulas. Now first of all, we have to calculate x minus x bar. We have to calculate x minus x bar. Now what is the value of x here? The value of x is 1, right? Now its sum is how much here? 3. Okay, so x minus x bar. So here 1 minus 3. So 1 minus 3 how much? Minus 2. Yes. Then what about next value? Next value is 2. X is 2 and 2. 2 minus x bar. X bar means what? 3. So 2 minus 3, 1 minus 1. So like we have to calculate x minus x bar. So after calculating all these values, then we have to find out another one. So this x minus x bar, what is x minus x bar? In linear regression, now why we are subtracting mean of x from the input value, that independent variable x? You may get question, right? Why? What that x minus x bar indicates, represents? Yes, the x minus x bar represents the distance through all the line y is equal to 3. That means here, so what is the value of y here? 3. Now here that x minus x bar represents the distance through the line, all the line y is equal to 3. Yes, because of y is equal to 3, now we have to find out the distances through all the line. Now we'll discuss one by one. Now here x minus x bar, already we have calculated x minus x bar. X represents independent variable and x bar is its mean of independent variable x. Now once you do that, the calculation, x minus x bar, the value how much? Minus 2. So we have to calculate, we have to plot it on the figure, graph. Now here minus 2. Where is minus 2 here? Now here, yes, y value is how much? 3. That means y value is 3 and we have to plot it. Where we have to plot minus 2 exactly? Yes. Now here, yes. How many? Minus 2, right? So 1 and 2. So here we have to plot it, minus 2. And what about next one? So 2 and 4, sorry, 2. What about x minus x bar? Minus 1. What about y value here? 4. Y value 4. So here on this line, what about y value? 4. So at 4, from here, what about value here? Once again I will repeat here. Yes, y value 4. Yes, we have to find out. Now what about x minus x bar? Minus 1. So move left 1 point. Yes, this is what minus 1. So this is what minus 2. Now what about next? 3. X is equal to 3. Then what about x minus x bar value is 0. Now what about y value? 2. So on this line, so where is that y value 2? Yes, at this line. So now here the what about result? 0. X minus x bar 0. So same line. This is what? Now what about next? X is equal to 4. Then what about x minus x bar? 1. What about y value? 4, right? Yes. Now 4. At 4. So on this line, at 4, then what about 1? Positive 1, right? So we have to move right side. So just move right side. This is what? 1. Now what about the last value? The last row? Yes. The x minus x bar, already I told you clearly, x minus x bar represents the distance through all the line y is equal to 3. Yes, this one. Y is equal to 3. As the last row here, x minus x bar is equal to positive plus 2, right? Now what about y value here? 5. So on this line, at y value 5, now x minus x bar how much? 2. Is it negative 2 or positive 2? It is a plus 2, positive. So we have to move right. So move right. 2 points at right side. So like we can plot all the values. All the values means what? X minus x bar. So in that way we can plot this. Yeah. Now coming to the y minus y bar. Now how to calculate y minus y bar? So according to the previous, the formula. So x minus x bar is finished. Now we have to calculate y minus y bar. Yeah. Now what is y minus y bar? Now we have to calculate. It's very simple, right? Yeah. What about y bar value? 3.6. Once you calculate all this value, we'll get 3.6. Now we have to calculate y minus y bar, 1 by 1. So once you calculate all the values, we'll get that table. Yes. Now these are all what? Y minus. So now y minus y bar, again I told very clearly in previous slides, y minus y bar is represents the distance through all the line x is equal to 3. X is equal to 3. Yes. Okay. Now we'll find out. Now y minus y bar minus 0.6 minus 0.6. Now okay. Now here, now what about value here? 0.6. 0.6. Yes. So here, now what about y? X value is 1. It's x value 1. Now we have to calculate 0.6. Negative, minus. So minus means what? We have to come down this one. If it is positive, move up. If it is negative, we have to move down. If it is positive value, you have to move up. Okay. Now what about 2? Next row. X is equal to 2. Now what about y minus y bar? Positive 0.4. Positive 0.4. At x is equal to. At x is equal to. Please, once again I am telling. At x is equal to. Because we are plotting on x values. We have to consider x values. Y minus y is represents the distance through all the lines through x. Right. Now 0.4 is the positive one. Clear. At x is equal to 2. at x is equal to, right, no positive 1. So minus 4, 0.4 at this line. So this is what this represents, minus this one, minus 6. Now next row, the y minus y bar, minus 1.6, minus 1.6. That means what? Negative, we have to come down. Along this path, we have to come down. Yes, we have to come down. Yes, where we have to come from? Where? From which point we have to come down? Then we have to consider x value. What about x value? This one. So 3. At 3, we have to come down. How many points? 1.6. Yes, we have to find. So this is what? 1.6. What about next value? Yes, this one. So here y minus y bar is 0.4 positive value. So from where we have to come? So we have to move up at x is equal to 4. So at x is equal to 4, yes, we have to move. Yes. Just 0.4. Yeah, 0.4. Clear? Now what about the last line? The last line here, the y minus y bar is equal to 1.4. The positive one, 1.4, right? Yeah. So from where we have to move up at x is equal to 5. At x is equal to 5, we have to move up. How many points? 1.4 points we have to move up. Yes. At x is equal to 5. At x is equal to 5. So we have to move up 1.4. Yeah, 1.4. Yes. So, like we can plot all the values. Right? So, now we have calculated x minus x bar and y minus y bar. Now, another one. So, according to the formula, so already I told that m is equals sum of x minus x bar and y minus y bar divided by sum of x minus x bar whole square. Now this part x minus x bar is finished, y minus y bar is finished, then we have to calculate what? X minus x square. We have to calculate. So this one. Now what are the values of this one? Yeah. The mean of x is equal to 3 and mean of y is equal to 3.6. Now this is the formula. Okay. See, this is what our linear regression formula. Yes. Once you calculate, we'll get the results of what? X minus x square. X minus x square. Now here, what is x minus x bar? Minus 2. Once you square it, we'll get it what? 4. Same thing here, x minus x bar minus 1. Once you square it, minus 1 square, 1. Yeah. Now what about next value? The next value x minus x square is what? 0. Once you square the 0, we'll get automatically same value 0. Now same thing, we'll do the remaining values. Yeah. Once you plot all the values, x minus x square, we get this line. So this is what regression line. So these data points we plotted here, it represents what? This one. Okay? Right. Now coming to the next one. Now we have to calculate what? X minus x bar into y minus y bar. So for the reason, yes, I have taken this one, the third column here, x minus x bar into y minus y bar. Right? So already we calculated x minus x bar and y minus y bar. Once you multiply it, we'll get it. Right? So x minus x bar is how much? 2 into y minus y bar minus 6. So once you calculate, we get what? This one. The same thing here. Once you calculate here, minus 1. X minus x bar is equal to minus 1 into y minus y bar. How much here? 0.4. So minus 1 into 0.4 is equal to what? Minus 0.4. The same thing if you calculate here, x minus x, this one and this one. So 0 into 1.6. So 0 into something is what? 0. Now come to next value here, x minus x bar 1 and y minus y bar is 0.4. 1 into 0.4, how much? 0.4. Now what about the last value? Yeah, x minus x bar is 2 and y minus y bar is 1.4. 2 into 1.4. 2 into 1.4, how much? 2.8. So like we can calculate x minus x bar into y minus y bar. Now once you apply all the values, x minus x bar, y minus y bar and x minus x square and x minus x bar into y minus y bar into our formula, we'll get the m value. We'll get m value. See this. So 4 by 10. So this, right? Yeah. So once you do that, once you put that m value and x value, so we know x value, right? So in that we got x value, m value. How much m value we got? We got 0.4. Then what about x value? X means what? Mean of x. So we calculated m value and x bar is already there. Okay. Now y means what? Mean of y. Mean of y. So we have in our hand we have three values. M is equal to minus 4, x bar is equal to how much? 3 and y bar is equal to 3 minus 6. So once you put it in all these values in our formula, y is equal to mx plus c, we get c value. So what about c value here? 2.4. Yeah. Yo. So c is equal to and y. Now how to predict data points? Yeah. So this graph represents all these points, the actual points. These are all actual points according to the given data. So already we have seen that, So this one. This is what actual data, right? X is equal to 1, 2, 3, 4, 5 and y is equal to 3, 4, 2, 4, 5. These are all actual points. So based on that, I calculated these values. Yeah, I plotted all the actual values. Then what about predicted data points? Now according to the previous calculations, yeah. So we have to predict it. Then how to predict? We have to apply, we have to put all the previous formulas. Right. X minus x bar into y minus y bar, x minus x square. After calculating those values, once you put it in y is equal to mx plus c formula, we'll find out all the values. Now here, the first one. So y is equal to mx plus c. Now what about here? 0.4. M value, right? X 1, 2.4. Now we have to predict values for this one. So we have to predict y values. So already the actual data is there with us, right? So this is what our actual data, right? So this is what our actual data. Now we are predicting YP. YP means what? So predicted values. Then how to predict it? Then we have to put it in formula. So here with us we have a M value, C value and formula is there. Now what about X value? This one. All these X values we have to predict the Y values. Just put it in. So Y is equal to 0.4 times of X plus 2.4. We'll get what? 2.8. 2.8. Now what about X value 2? Now X is equal to 2. Once you put this X value in the formula here, Y is equal to M value is 0.4 into x value is 2 plus 2.4. So we'll get here how much? 3.2. Right? Yeah. Now we have to plot. And once up you apply again, x is equal to how much? X value, once you take x value 3, then okay, y is equals 0.4 is m value and 3 plus 2.4. What about 2.4? The c value. What about this one? X. This one m value. So once you do it, you will get 3.6. So like we have to calculate all the values. After calculating all these values, then we have to plot it. Yeah. So these are all what expected values. They're all expected predicted values. Now what about this one? So this is the actual value. This one is what predicted value. So once you plot it, after plotting the predicted values, now draw the regression line. Yeah. So that line is what a line of regression. Yes. So that line will go through the predicted values. Clear, students? Yeah. These are all what? Predicted values, right? Predicted values. After predicting values, now the line will go through all these predicted points. That line which is passing through the predicted value is called as line of regression. Yeah. Now we'll come to the, already we plotted actual values and we calculated the predicted values. That means y is there and yp. Now what about y? Y is actual value and what about this one? Predicted values. Now we have to calculate error. Right? How our model is good. Is it a good model or bad fit or good fit? If it is good fit is enough. If it is bad fit, again we have to repeat it. We have to reduce. If it is bad fit, how much error the model goes down. If it is more error, the model has got, then we have to reduce it. We have to minimize it. That is possible by using mean square error. So that mean square error will calculate the distance between actual and predicted values. Now what about goal of this one? We have to find out error. We have to find out error and we have to reduce that error between what? Actual data points and predicted data point. That means y minus yp. So what about y here? Y means what? This one. What about yp? This one. So this is what y and this one is what yp. So this gap indicates what? Error. So we have to reduce the error. We have to reduce this error. The goal of this mean square error is to reduce the mean square error between actual and predicted values. Now friends, once you look at this figure, since first slide onwards, just we had only x values and y values. X is independent variable and y is dependent variable. Based on that, we plotted the values. This, green dots indicates actual values and red dots indicates what? Predicted values. Now we have to calculate error between these 2 points. After finding error, if error is more, then we have to reduce it. The line through the least error is called the line of regression or best fit line. That means this one. So this statement indicates the line through the least error. So means what? So this is what? High error between these 2 points. So here very least error is there. So if it is least error is okay, then best fit. If it is more, it is not a best fit, then we have to reduce it. Okay. Now, yes, at this I am concluding this today's my class session. Okay. In next video, we'll discuss the practical implementation. The practical manner we have to implement this mathematical understanding of the machine learning model. That means linear regression. We'll implement linear regression in machine learning with help of TensorFlow in next video. Right? Yes, today we discussed about mathematical understanding of linear regression. The formula of linear regression is y is equal to mx plus c. Yes, so we have to calculate m and c values. Okay. Now y value and x value already will get, right? So y we have to, the actual value. Then yp means what? We have to predict the values. So after predicting yp, then we have to calculate error, y minus yp. Okay, that is what error. The goal of mean square error is to reduce that error. Right. How to reduce that error by using mean square error, we'll discuss in next video. After that, we'll try to implement linear regression in machine learning with TensorFlow. Till then, bye-bye.
Like, share and subscribe. Hit the bell icon for more updates.